Hello and welcome back to Azure Terraformer. Today we have a special episode. I recently had the opportunity to present at the Azure Terraform community call, hosted by some of my great colleagues here at Microsoft, Stephen Ma and Mark Gray from the Azure Tools division. This is a call that is not exactly monthly or quarterly, but it meets usually once every 1 or 2 months to talk about different things. And I guess they were running low on presenters this week because it was just little old me. You can go check out the entire meeting on their YouTube channel, which is one of my featured channels, and link in the comments below when it becomes available. But I thought I would share with you on my channel my talk about Terraform, Ansible, Packer, when to use which, when to use them all, and how to do it. So without further ado, let's get started.
I will turn it over to Mark Tinderholt. Mark is also more affectionately known in the community as Azure Terraformer. If you've ever seen this goofy guy make a hilarious video, then I'm sure you'll know who he is. We personally got to meet him at HashiConf, and he's great. Really funny guy and really cares about Terraform. And a full disclaimer, he does not work on the Terraform team. He is not here to give prescriptive guidance on behalf of the team on the truths of Terraform on Azure. He is just a really passionate dude who does this because he loves Terraform. So really appreciate him. I'm going to hand it over to him and let him take it away. Thank you, Mark.
Thanks, Stephen. So that disclaimer, don't listen to whatever I say. It's not official Microsoft stuff. I just hack a lot, but appreciate the intro. And let me share my screen over here. So I promise I'm not going to have a lot of slideware, but one of the things that I'm trying to get better on my YouTube channel is maybe give a little bit more diagram context of what I'm about to go code. So I thought I'd start with a little bit of that today. So a little bit about me. I work at Microsoft. I have to announce that on social medias and publicly whenever I talk. As Stephen said, I do not work in any way related to Terraform at Microsoft. I'm just a user of Terraform. So you can call me an amateur Terraformer. But in a former life, I've used Terraform, in a variety of ways on AWS, on Azure, on GCP, experimented with things like, the Kubernetes provider and things like that. Stitched together in a lot of different ways with a lot of different tools and different pipelining tools, and just fell in love with it. I just love it. I think it's a great tool. And, that kind of fuels that passion. It's a lot of fun, working with Terraform. And so when I get an opportunity at my day job to work with Terraform, it's awesome. It's a wonderful thing. But we do a lot of like bicep and ARM internally and things like that. So those are not always a given. But anyways, this is me. I'm an amateur YouTuber. I felt like there's a lot of AWS content out there around Terraform. Like you throw a rock and in the Terraform world, and you're probably going to hit an AWS guy who doesn't know anything about Azure. And so I thought there was a gap in the community, like about, real practitioners using it. I'm not saying I got all the answers. I've just been working on Azure for a long time and working with Terraform a long time. And so I thought I'd put them together. Niche of a niche on YouTube. That's my retirement strategy. We'll see how it works out. But it's been a lot of fun and engaging with the folks that, watch my stuff and watch my ramblings. And I learn a lot of stuff actually from questions and comments that people leave. So it's been a heck of a time. I'm having a great time. So today, I was going to talk about a topic that I haven't hit yet on my channel, which is Ansible, right? And you guys may have seen my recent parody video, which it still cracks me up when I watch that thing. And the total eclipse of the heart is ingrained in my brain for like a week now. But it's a gentle jab at some of the other tools out there, and And I think that video is not trying to say other tools are bad, right? It's just like there's passion and there's love for when one tool does its job really well. That doesn't mean Terraform is the tool to end all tools. It does everything. Terraform just does its job freaking awesome. Yeah, somebody's out there. Hey, Steven, can we mute the little baby? Hi, baby.
Hi, baby.
I don't speak baby. I suppose we all speak baby.
That should have solved it.
Thank you, sir. Yeah, so the thing about Terraform is that it plays well with others, right? I mean, it does its job really well, and there's a lot of tools out there that do their job really well, right? And so I don't take that video as a thing that I think that Terraform is the only tool there is. It's just a really cool one. And as you know, I've worked with a tool called Packer a lot on my channel, and I have not worked with this tool called Ansible on my channel a lot, but that's going to change. And because I think Ansible is a great tool. And so I thought today I would just kind of show, a basic way that I've used Ansible with Terraform and Packer actually together to kind of leverage the strengths of each of these tools kind of in combination with each other. And so I have a code base out in GitHub. You can pull down all this code. I got it working literally this morning at 8 a.m. You can check my commit history. So kind of procrastinating on this one, but it works. At least it worked at 8 a.m. I put some delete locks on my resource group so nobody deleted anything. So hopefully we won't have trouble with the demo. But basically this is how this works, right? Over here, we have, can I use a little pointer? I guess you can see my mouse. We got Packer, and Packer, we describe what's going to go on the virtual machine. And we use Packer to basically bake an image, a virtual machine image. And the code base that you can go access on GitHub, basically I'm provisioning an Azure Compute Gallery, and I'm provisioning an image definition. And Packer, once those things are there, Packer will go, if it's pointed in the right direction, it will go take this HCL template that has how I want this virtual machine to be configured. It'll execute those commands, and it will bake an image, and it will save it as an image version within that image definition. So that's step one. And so Packer is a great tool for anything that is really slow moving, that's big, that takes a lot of time, that you're not going to change a lot, right? So if you're installing, big software, configuring, files and things like that, you can bake that into your Packer image to save time when your virtual machine scale set is going to scale out, your workload to handle those spikes in traffic. If you don't bake that into Packer, well, you can still scale out, but you're gonna have to do all that heavy lifting in post provisioning, right? And so having it built into the image, it's kind of like it's compiled in there, and you really just have to wait for the VM to become healthy and light up, right? And then usually there's the last bit of thing that you need, which is what I call kind of last mile configuration. It's where there's certain things that you don't know until you spin up the VM. Like these are runtime specific configuration. This could be like DNS, or it could be an IP address of the load balancer, different things like that you need to, or different environment variables, right, that you need to pipe in so that your application, code that's probably baked into your image, when it wakes up, lifts its head, and it's like, oh, okay, who do I talk to? Like, where's my SQL database? Where am I getting traffic from? Who do I need to talk to do service discovery, things like that. That stuff you won't know at the time of baking the image. And so this is where post-provisioning can come in really handy. And there's a lot of different ways you can do that. And, virtual machine extensions, you can You can add some cloud init, some user data to your Terraform code. But again, it comes back to which tool does the job really well. And Ansible is a fantastic tool for pushing updates fast to existing virtual machines, right? So if you want to do patching of an existing environment, if you want to do real-time config changes, right? Maybe there's some drift that's been injected into your system and you don't want to shut down VMs. Ansible is a great way for pushing those config updates to those virtual machines so that you don't have to, you can minimize downtime and minimize outages. So again, different strategies for getting basically the same job done, which is how is my operating system configured? How is my application configured? And they each have their strengths. And so here in this code base, I'm using them in conjunction with each other. And I have a Packer template. I build a very mundane image. You're going to laugh. All I do is run app update and apt upgrade. That's it. And then I have some Terraform code that provisions a virtual machine scale set, a few VMs, a VPN gateway so that I can connect to it and run Ansible, because I haven't automated the Ansible in a pipeline yet. And it doesn't really demo well, but you'll probably see more about that on my channel. And then I drop an SSH key, a shared SSH key into a key vault, and I use that for my VMs. And I'm ultimately going to use that to connect with Ansible. So that's kind of how it works. Any questions about the architecture? But I'm going to double click on the interface between Terraform and Ansible. But this kind of gives you a broad picture of what Packer's doing, what Terraform's doing, and what Ansible's doing. Tim.
Yeah, we have a similar thing coming up. We hadn't even considered using Packer to build a VM image. And I'm curious, what is Packer using as the file format to put that in the compute gallery?
So Packer, the file format, it actually produces a managed image out on Azure. Oh. So the Packer, just like Terraform, it has a plugin framework, strategy pattern, right? Where you can target different platforms. There's, as you might imagine, an AWS. Actually, there's a few of them. An AWS plugin. There's a GCP plugin. There's an Azure plugin. And they can be configured in a lot of different ways. But what it ultimately outputs is a virtual machine image, and then in a resource group. And then you can configure the Azure plugin for Packer to target an Azure compute gallery so that you can take advantage of the coolness of a compute gallery to kind of add some structure, around, versioned history of images and things like that. So does that answer your question? Did I hit all?
Absolutely. Yeah.
Okay.
Thank you.
Yeah. And actually, I've even at Microsoft, I've used this strategy, and we've found ways, where we can share code between basically the scripts, bash scripts that do the install. We share code between Packer and Ansible, such that when Packer bakes it into the image, like when we run Ansible, Ansible's going to go and do the same check to make sure the things are there, and that way we only have to update the operating system configuration one place. Next time the image gets built, we're going to spit out a new baked version of whatever Ansible is going to make. So, right. But it allows us to spin up new environments with the new hotness. But with Ansible, we can, immediately touch our existing environments and update that configuration with the new hotness immediately while minimizing downtime. So I think I'm also going to spend a little bit of time on my channel talking about, how you can share code between a Packer template and a set of Ansible playbooks. So, any other questions?
I think you might have just answered it in the last bit there, but I come from a world where we use Packer and Ansible a lot, especially with physical infrastructure. But with Azure, we're I've almost been pontificating about like cattle versus pets and immutable infrastructure. So do you still see a play for Ansible in that immutable infrastructure world, or is it just kind of what you said there? I think you answered it though, like that quick hits use Ansible, but then fill your playbook back to your Packer template. And is that kind of what you're thinking for the long term?
Yeah. And I mean, Packer helps us get closer to the kind of the holy grail of immutable infrastructure with virtual machines, but virtual machines are not as nice as like Docker and Kubernetes, and like as just being able to quickly push an image and have that thing like insta fire up, right? So I think when you're managing production systems using virtual machines, it's really hard to achieve full immutable infrastructure like practices, just because of practical realities of like the engineering that it would take. I'm not saying it's impossible, but the engineering that it would take, to achieve that. I mean, you'd basically be having to do a lot of crazy stuff, like with blue-green cutovers and, a lot of stuff on the load balancer, intelligence on the load balancer to spin up new VMs and then kind of siphon traffic away from the VMs that are going to go away. Because with virtual machines, you literally have to pop them in the head, right? And then spin up a new one from a new VM. So there's, I guess, some physics involved that just makes it cumbersome with VMs.
Got it. Yeah, that's good. That's a good point. Like I said, I don't know if I said this, but we're not doing a lot of IaaS right now with Azure. A lot of it's PaaS, but in SaaS. But there is a conversation. We have a lot of stuff in Rackspace, and we're kind of thinking about moving it to Azure. So they're talking more about IaaS in Azure. So it's becoming a topic.
Yeah, and I would say I think the strengths of Packer and the strengths of Ansible can be applied, within the realm of where they make sense. And Packer is about, speed of launching VMs, whereas Ansible is about speed of applying updates to existing things, right? So if you want to, and this Packer, like baking it into the image becomes really important when you want to dynamically scale, right? Because you don't want to wait for Ansible to if you scale out a bunch of new VMs that are using marketplace images or just baseline OS images, and then you use Ansible to update them. And then they say, okay, Ansible's done with me. I'm ready to actually do stuff now. I mean, there might be a crap load of stuff that Ansible has to do in order to get that thing traffic ready, right? Not just OS healthy ready, but hey, I can actually be productive and handle traffic now. And that's baking that in the image. It's literally you just spin up a VM. Once you get closer and closer to, traffic ready gets closer and closer ready to OS health ready, right? And it's it's almost insta. So there's trade-offs that you got to evaluate there. Cool. Thanks. Good questions. Any other questions before I move on? Okay. So this is kind of what the handoff looks like between Terraform and Ansible. So Ansible, like Terraform, is a command line utility that processes code in the form of YAML files, as we saw in the previous diagram, and basically goes out and through SSH talks to virtual machines and evaluates what the configuration of that machine is. And so what a couple of really important things that Ansible needs: one, it needs an SSH key, right, that it can use to communicate with those virtual machines. Two, it needs to know what virtual machines to talk to, this is called an inventory. And then three, there's probably some variables, right, that need to be piped into Ansible to set the context so that, certain runtime attributes like who's the database, what managed ID, should be used, et cetera. Those can be piped in and inform the playbooks that Ansible is going to run against those virtual machines. So a technique that I've used, and I know there's an Ansible provider out there, that thing dropped pretty recently, and it dropped right in the middle as I was building my own like solution like this, where we were using Packer, Terraform, and Ansible together, and so I didn't have a chance to evaluate it. I'd be curious if once you see my approach here, if you have experience with the Ansible provider, I'd be curious, what your thoughts are with that. But basically, my approach here is Terraform is responsible for provisioning the virtual machines, right? And basically, it has all the information, that I need to populate the inventory and the variable inputs to Ansible, because Terraform knows what managed ID those virtual machines are attached to those virtual machines. It knows the private IP address of the VMs, the host name, any custom DNS we're using. It knows everything. And so I can, in my Terraform, using a local variable or a local object, I can construct a data structure as a local variable, and I can use a Terraform function called YAML encode, and I can spit out a YAML file that looks exactly like an Ansible inventory file. And likewise, I can spit out a var file that looks exactly like an Ansible variables file. And so really it's just a matter of once Terraform spits those things out, either through Terraform out or local file resource, it's about piping those into like where the Ansible command line is going to execute, right? So it's kind of like Terraform. Ansible is kind of like Terraform in that way, in that it operates from a working directory, and there's certain, magic files that it looks at, in order to set its context. And when you run an Ansible playbook, just like Terraform, you can kind of run in a, read-only mode, like, hey, let's go detect what the deltas are, which is this command line, except with -- check, right? So it's not exactly the same vernacular, but it's the same concept, right? It's just Ansible is going to go talk to the VMs, analyze the state of the VM as it compares to what the playbook, has in its plan to execute, and see what is changed and what actually needs to be executed on the VMs. And once you want to go actually make that so, you just remove the check and you run this command, and Ansible will go fire all those things and make it happen. So pretty parallel concepts, but they do very, very different. They're hitting a different control plane. Whereas Terraform hits the Azure ARM control plane, Ansible is literally SSHing into the VM and running commands. That's it. Any questions on this before I move on? We're going to look at all this code right now. This is my last slide, so we're going to dive into it. Any questions before we dive in? And I know going a little over on time, Stephen, I hope that's all right. But I think I can, once we get into the code, I think I can wrap it up here pretty quick. All right, no questions. Here we go. So, bada bing. So here's my code base. Let me make it a little bit bigger, okay? And so the structure of the code base, I have a source directory, which has my Packer code, my Terraform code, and my Ansible code. And, the Packer template, it's all HCL, just like we talked about. This block right here is basically telling Packer how to talk to Azure. This block right here basically saying, hey, Packer, once you got a VM up and running, this is what I want you to go do on that VM, right? And where you'd have kind of crossover between Ansible and Packer is through bash scripts, right? So you can see here I'm using inline bash, right? This is not the way of sharing code between Ansible and Packer, but the way that you would do it is you'd share bash scripts between your Packer template, which your HCL would then reference those bash scripts, and those would be the same bash scripts that your Ansible code would reference. So I didn't, for this simple demo, I didn't do that, but I'm just thought I'd point that out there. There we go. And then, so looking at the Terraform, I have my main, and this is pretty standard Azure stuff. I got my resource group. I have my compute, and where using Ansible to manage existing systems, it's not when you got like one VM. It's when you got like a cluster, a whole bunch of them. And usually it makes sense when you've got very stateful workloads, like massive MongoDB or Cassandra workload, or even Vault or something like that. I don't know. So I set up a little module here, and the where I use this, we had an active cluster. Basically, we had a VM scale set in each region that was multi-zonal, and we balanced traffic across those clusters or data centers, right? So in my real world example, I would have like several of these clusters, and they would all hit different regions. For my little demo today, I just have one of them, and it produces 3 virtual machines. But you can see I've got, at the cluster level, I'm specifying some things that are cluster specific, like how many nodes do you have, Mr. Cluster? What region do you want to go to? But then there's also VM specific config, like what SKU should you use? What SSH key should you use? What should be the default admin? What subnet are we going to spit these guys into, right? So those things are set up at the cluster level, and then I'm using local modules to keep things simple. Looking at my cluster, I have a VM scale set. This is an orchestrated VM scale set, which uses the orchestration mode. And then I have, I'm using count. Don't hate on me, okay? I'm a simple creature. I still use count sometimes when I'm doing quick and dirty. Laugh all you want, okay? It's easy. It's quick and easy. I don't have to convert things to a map. But anyway, so here I am just creating 3 nodes in my cluster and configuring some disks and things like that. So that's pretty much it, right? And what this produces, let me see if I can find it over here, is I've got this resource group that's got some nodes in it. I got a VM scale set. I got a virtual network, and I got a VPN gateway. And for the sake of this, I have set up the VPN gateway. So I'm already connected to it. Okay, so I think I'm good there. Now remember, I said earlier, Ansible communicates over SSH. So you got to have network line of sight to this stuff. So if you're going to run this in GitHub Actions or Azure DevOps pipelines, your build agent is going to have to be connected to your network. Okay. So this is why I'm using point-to-site VPN. I'm literally just jamming my little MacBook here onto the same network as my VMs here so that I can run Ansible. So that's what I'm going to do right now. So over here, here's my script, and you can see, like a good little boy, I've been doing some testing before this demo, but I can run this command right here, and I'm going to run check. And hopefully all goes well. I swear to God, there's not many times where we're going to watch paint dry, but running Ansible here, we'll see how the network responds. But now you can see I'm getting okay, and I see a bunch of private IP addresses, and that's basically in the Ansible inventory. Ansible's going out, pinging each of the virtual machines, connecting to it, and then running the YAML playbooks against it to see like what it needs to go do. Right. And in my Ansible playbook, it's just like trying to update the latest, some version of Python. So it's not anything fancy, but you can kind of get the idea of how this stuff works. So while that, we can see that thing's running, and it says, okay, nothing changed. And this is very similar to like a Terraform plan, right? It's like, what needs to be changed? In Terraform, it's like created, destroyed, changed in line. Right. So the same concepts kind of apply, and you can see I got OK 6. That means 6 things are as expected. So I don't have to do nothing. Right. And no changes. So this is good. This means there is no drift. So how does this work? Right. Looking at let's go back to my code here. Looking at the Ansible directory, okay, the way this works is I have this YAML file right here, and I'm generating this YAML file as an output in Terraform. I literally am creating this structure because this is the structure that Ansible has been set up to use. Ansible has this concept of all nodes, and then you can set I made up this. This is a creative writing exercise. I just called them cluster. I could call this Marky Mark and the Funky Bunch, right? And as long as there's a corresponding, group of that, in the config, it's gonna run the playbook on it. So right here. So I've got roles common, and I've got my group of hosts called cluster. This is where Marky Mark and the Funky Bunch would go. And then, yeah, I'm not very creative. I don't claim to be. But you can see here, I'm using roles common, and that hits this directory. And inside here, I've got more YAML files that basically go do the things, right? And in this, I'm dropping an Etsy profile and doing some fun stuff like that, right? So this is all, this is not new to like Ansible people, but, dropping the inventory file is kind of where the rubber hits the road from a Terraform standpoint. And so all I do is in my Terraform code, I simply build, and this is gonna look a little scary, but these two objects right here are my local variables that I just YAML encode and output to a file, and that is the exact same file that I'm using in my Ansible directory to go talk to these machines. So also interesting, I wouldn't do this in production, but I also happen to be generating a TLS key. So the SSH key that I'm using, I drop this in Key Vault. I provision the VMs with it. I also dump this to a local file so that, when I run Ansible, I've configured Ansible to use the same SSH key. So you can go pull this. Yeah, this is on a public repo. You can go pull this code, and I've tried to design it so that it'll work. Like you can just clone this repo, and it'll just work out of the box. You just have to, provision some things. You have to provision the Azure Compute Gallery, which is in this folder right here, the gallery folder. You have to provision the application, which is my cluster. You got to run Packer to put the virtual machine image out there. And then once all that's done, Terraform apply will put the inventory, the vars, and the SSH key in this Ansible directory so that you can go run Ansible. But you got to connect to the VPN. So I'm trying to make it sound simple, but there's a few things going on here. But if you got site to site, and or like Express Connect or something like that, like it would be a lot less work to get that done because you already got network line of sight. So, any questions after looking at the code? What's the role of Terraform? How do we get the things out of Terraform into Ansible? Any questions on this? Is this making sense? I've stunned them with silence. Okay. So that's pretty much it. That was my demo. Ansible's great. Terraform's great. Packer's great. They all do different things. You just got to use them for what they're really great at, and that's the bottom line of picking the right tool to do the right job. So, thanks everybody. Well, that's it. That was my talk. I had a good time. There were some good questions and some pretty good engagement from the audience there. We're trying to make that call a little bit more of a group, activity as opposed to just talking heads. So I thought it was awesome that, people just popped off mute and asked questions directly. Maybe even some will be brave enough to come on video someday. We'll see. Anyways, love to see that community developing around Terraform and Azure. Anyways, that's it for me. Until next time, this is the Azure Terraformer signing off.